Hey everyone, it's Casey, and today we're going to be talking about the IUPAC naming in cycloalkanes. The system is pretty similar to naming alkanes, except there are a few tricks. Now, if your teacher's only going to put a couple questions on this stuff on the final exam, chances are they're going to want to put these tricks to make sure you learned, your naming really well. So I'm going to show you guys the protocol you're going to want to follow when naming anything with a ring in it, because likely you're going to have a trap that I'm going to show you right now. So we're going to look at 3 compounds. And each compound I'm going to give it to you for a specific reason to make sure you get everything down, because it does get a bit confusing. All the rules start piling up and you got to see which rules are more important than the other. So I'm going to try to clear that up in this video. So the first one we're looking at, we have a ring, and the ring, it's a pentagon. It looks like a pentagon. It has 5 sides or 5 carbons, so that's cyclopentane. And we see over here we have a branch, and the branch has 2 carbons on it. So anything with 2 carbons, we normally call that ethane, and since it's an alkyl group, we drop the ane ending, and it will be an ethyl group. Now, before you want to go in and start writing the name, you're going to want to make sure you identify the parent compound. The parent compound is going to be the thing that appears at the end of your name. It's going to be the last thing. So you can assume that we're going to have something before, and then we're going to have something after. So this is going to be your branch, or your branches. If you have many of them, you would name all your branches, and then at the end you would mention one last thing, which would be the parent. Now, the parent is always going to have the most amount of carbons, so you need to take this into consideration. So where do we divide the branches from the parent? We don't know what the parent is right now, so we're going to want to just divide like this, and we're going to want to look at the right side, and we're going to want to look at the left side, or just separate it. We want to look at the ethyl branch, and we want to look at the cyclopentane. So the cyclopentane, this whole part over here, has 5 carbons. So erase that, and the ethyl branch over here only has 2 carbons. So with that reasoning, we can assume that the cyclopentane over here would be the parent compound and would appear at the end of the name of our entire species over here. So we can write that in right now. We know that our whole thing is going to end in cyclopentane because it has more carbons. Always check this, because I'm going to show you an example later on. It might not always be the case, and you might just see the ring and want to put the ring at the end, but in reality, the ring would be the alkyl group and would appear right here. So it could be something like cyclopentyl, and then you can write something here that would have more carbons. We'll look at it in a second. So what do we name? What's our branch? Well, we know that it has 2 carbons. I said it before. It's an ethyl branch. Ethyl. Misspelled that. Let me fix that up for you. There we go. All right. Ethyl. It's an ethyl branch. It has 2 carbons, 1 carbon, 2 carbon, ethyl, and we can just write that right there. Since there's only one substituent on the ring, we don't need to put the 1 hyphen in front. You can put it if you want. It's not technically incorrect, but it's really not necessary. So the full thing, all one word, would just be ethyl cyclopentane, and everybody would assume that this would be carbon number 1, even though you don't mention it, because you're always going to start numbering from the first branch. That's the standard way of naming. So our compound is ethyl cyclopentane. Moving down, we're still going to first start off by identifying where is our parent compound. We're going to look at all the branches individually. So these 2 methyl groups over here, they each have 1 carbon, so they definitely don't have more carbons in the big 6-sided hexagon ring, or cyclohexane. Here we have an ethyl group, like we saw before, which has 2 carbons on it, and once again, 2 is not bigger than 6, so we can safely say that our cyclohexane is the parent compound, and we can continue using that. It'll be the last part of our name. Now, how are we going to number this? Now we have different, we have more than 1 branch. We do need to take into consideration putting numbers in. So, like I said, the same system always applies. You want a number, so your first point of difference is going to be attributed with a lower number. So you don't want a number starting from over here. It is tempting because, ethyl group, the E, would come before methyl, M, when you're alphabetically ordering them in the name, but then you can realize that there's 2 groups right over here. You really don't care what the branches actually are. You just want to have the lowest numbers. So you'll start your numbering right over here. Number 1, number 2, number 3, and just, to put it up, 4, 5, and 6. So we have 2 methyl groups. Remember, 2 methyl groups. We're going to want to use that Greek prefix di. Write that over there. Just something you always want to take that in consideration, not when alphabetizing, but when considering it, writing in your name, you're going to want to include that. And we're going to have 1 ethyl group over here. So we can start putting our name together. We know that the ethyl, which is on number 3, the E comes before M, so that will be the first thing in our name. We'll have 3. That's the carbon it's on, hyphen, ethyl. Now it's time to talk about these 2 guys over here. Both of them are on 1, and you need to write 1 twice. Another hyphen, 1, comma 1. Always separate numbers by commas. Another hyphen, dimethyl, because there's 2 methyls, so you need to indicate that. Dimethyl cyclohexane. They're running out of room there. You see how long these names get? Yeah, it does get pretty tricky. So you really want to know all the rules. Now we'll look at this one last time. We see the 3 tells us that's where the ethyl group is. The 2 1s tell us that's where the methyl groups are, and also the di tells us that there is 2 methyls. And if there was 3 methyls, you'd write tri, and you'd have 3 numbers out here. And the cyclohexane tells us what our parent compound. It tells you what everything is attached to, and it makes it easy for the reader to visualize. If you just give them 3-ethyl 1,1 dimethyl cyclohexane, they can visualize what it is, or they can draw it out. And it's pretty simple. It might seem complicated at first, but once you see stuff that's even meaner than this, you'll get to realize that this is actually a pretty harmless compound. Now, this is where it becomes important on looking at our parent compound. This is a little bit tricky, so you want to keep that main rule before dealing with anything. As soon as you see a ring, you want to find your parent compound. So let's see. This over here, there's 4 carbons in this square, and we call that cyclobutane. So we'll write 4 carbons. Now, what about this branch right here? This is all one branch. You look at each branch individually. 1, 2, 3, 4, 5. Uh-oh, we no longer have our ring as our parent compound. We have this pentane right here, a 5-carbon straight chain alkane with an alkyl group, which happens to be a ring. Alkyl group. An alkyl ring. So what do we do in that case? It's really nothing different than any other alkyl group. We would normally call this cyclobutane if it was on its own. Right? Like we saw last video, a simple square on its own would be cyclobutane. So no different. Cut out the A and E ending and replace it with YL to be cyclobutyl, and just use it as an alkyl group. So we're going to number this to give the lowest number to the alkyl group. It doesn't matter which way you number it because it is symmetrical. So we have 3. It's on carbon number 3. That will give it the name 3-cyclobutyl. Keeping that YL ending because it's no longer on its own, pentane. And simple as that, we have pentane to indicate our parent compound, which has the most number of carbons, and we have our branches. Or our branch in this case is only 1 branch, and we know exactly where we can find that branch, and everybody's happy. So we can visualize the structure right here. So that's one little trick. I guarantee every teacher who thinks they're funny is going to put this on the final. You really want to look out for it. Don't give them the satisfaction of falling for their trap. Know this. Know that when you see a ring, there is a chance that that ring will not be the last part of your thing. You might be very tempted to come up with a really wise name for this structure right here when putting it on as an alkyl group, and it's going to be much more complicated. So if you can just look at it right now, identify it's not the parent compound, you'll save yourselves a lot of time, a lot of struggling, and obviously you'll save yourselves a lot of marks. So that's the main video. These are the main things you really want to know when naming cycloalkanes. You really want to know what comes first when numbering. You want to know how you put the name together, and you want to know what's the parent compound. So if you have any questions, leave them below, and I will see you guys next time.